Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
In this problem, we don't have constant acceleration, so we cannot use the cheat sheet, but we have to resort to calculus instead. So the problem is as follows. At T0, the current to a DC electric motor is reversed, which results in the angular displacement of the motor shaft, which is here, given by this expression. So the angular displacement any given time, that's expressed like this: some constant times t minus another constant time t squared minus yet another one c t cubed. And we have a is 250 radians per second, so we can note it as just like 1 over second. B is 20 radians per second squared, and C 1.5 times 1 over second cubed. And A, at what time is the angular velocity of the motor shaft 0? So we have displacement. How do we get angular velocity from there? In general case, the angular velocity at any given time is the time derivative of the displacement. So when we take derivative of this guy, at minus bt squared minus ct to the third power over dt, we get a minus 2 bt minus 3ct squared. And what time is the angular velocity 0? So we have to solve for this. So this becomes second order equation, and we get the times to be minus b, so minus the second term 2b plus minus 2b squared, so that's going to be 4b squared minus 4 times this and this, so plus 12 times ac square root divided by 2 times whatever is in front of the second order term minus 6c. If we put in these values, we get, of course, two answers. So first of all, minus 13.1 seconds, and then plus 4.23 seconds. And of course, only the positive value makes sense. Time cannot be negative, so that's the moment in time when the angular velocity goes to 0. In part B, we want to know what is the angular acceleration at this very instant, at 4.23 seconds. So first of all, we have to find expression for the angular acceleration, and that is just the time derivative of angular velocity. So we are differentiating this expression, so a minus 2b t minus 3c t squared with respect to time. And the constant term a disappears, so we have minus 2b minus 6c t. And then we can plug it in. So at 4.23 seconds, we get minus 2 times b times 20, 1 over second squared minus 6 times c, which is 1.5, 1 over second cubed, times the time, so 4.23 seconds. And this gives minus 78.0 radians per second squared. So second and second cancel there, so you have consistent units. So about minus 78 radians per second squared.